Okay, and thank you everyone for joining us. This is a webinar presented by the International Society for Quality of Life Studies. We're thrilled to have our presenter here, Sarah Fleche. Sarah, excuse me, is an applied economist and CNRS research fellow at the Sorbonne Economic Centre, University of Paris in France. Her research lies in the fields of labor education and behavior economics, and has led to new insights into the role of schools and on well-being development, mental health, and determinants of well-being over the life course. Sarah is also an associate researcher at the LSE Centre for Economic Performance and the French Wellbeing Observatory. In 2008, together with Andrew Clark, Richard Layard, Nattavudh, I mispronounced Nick, I know him as a Nick Powdthavee, and George Ward, she wrote a book on the origins of happiness. And Sarah, I hope we can share that book at the end of our webinar. We'll send a link out for that book as well. Prior to joining Paris One University, she has been an assistant professor at the, you'll have to help me with this pronunciation, Sarah.
Marseille.
Marseille School of Economics, my apologies, a postdoctoral researcher at the LSE, and received her PhD from the Paris School of Economics. I also should mention that Sarah was the 2022 ISQOLS Award recipient. She was one of our Young Scholar Award recipients, and we're very, very pleased to have Sarah presenting today. And with that, Sarah, I will go ahead and turn it over to you.
Well, thanks a lot, Jill. I'm very pleased to have the opportunity to present this paper. So thanks for the invitation. So today I will talk about teachers and how teachers can improve students' well-being and affect their long-term success. So the motivation is the following. So we know that non-cognitive skills are important. What I mean by non-cognitive skills, well, I mean self-esteem, for instance, perseverance, the ability to adapt to shocks, but also social skills and so on. So we know that those skills, the non-cognitive skills, are very important to succeed at school for academic performance, but also later on the labor market. But it also can affect other outcomes like health, social relationships, and so on and so on. So we know that these non-cognitive skills are important, and they are becoming more and more important. So it raises some important questions. First, we know that non-cognitive skills are not distributed equally across people. So there are some inequalities in non-cognitive skills. And the question is, so if we manage to improve non-cognitive skills for some people, would it help to increase social mobility? Would it help to help them to perform better in terms of academic performance or labor market outcomes? So can we think about early intervention to help people improve their non-cognitive skills? And the second question it asks is whether, okay, what can we do? What are the determinants of these non-cognitive skills if we want to improve them? So what should we do? What are the factors that are important? Is it family, the family environment? Is it other things? And in particular, if we look at the work by, for instance, James Ekman in particular, he says that if we want to deal with these inequalities in terms of non-cognitive skills, we should try to intervene early. And if we do so, if we intervene early enough, we can be able to reduce these gaps across people in terms of non-cognitive skills. So if we think about early intervention, we can think, as I have said, we can think about the family environment, but we can also think about the school environment, what is going on at school, and can school, and in particular teacher, can play a role in improving children's non-cognitive skills? So this is the question I'm asking here in this paper, is what's the role of schools and in particular teachers to improve students and pupils' non-cognitive skills. And if we look at the literature, in particular in economics, most of the literature in education have focused on test scores, the impact of schools and various school variables on students' test scores. We know little in economics on the roles of school, on behaviors, well-being, like other outcomes that could also be very important for later life success. And if we think in terms of policy, if we think that schools have a role to play in terms of improving non-cognitive skills and well-being, then we can go a step further and ask, okay, so now we evaluate school in terms of how much they improve test scores, students' test scores, but should we also try to include these non-cognitive skills and well-being in schools' evaluation to see, okay, how much schools perform in terms of students' well-being and try to maybe choose between different schools based on their effects in terms of non-cognitive skills. So why teachers? If we think about schools, why I'm interested in teachers in particular? Well, because if we look at the literature in education, there is a consensus that says that teachers are one of the most important components of the schooling environment. And to reach this conclusion, the standard approach in the literature is to compute value-added measures. So what is it? Is it that for each teacher, you will compute how much gains students will have during the years they spend with this teacher. So comparing okay, the test score they have at the end of the year with the test score they had at the end of the previous year. Okay, so you do the difference between the two, and you see the value added a student have with a teacher, with a particular teacher during the year. And so then you can compute this value added for every teacher. And actually in the US, schools have started to use this type of measure to evaluate teachers. It means that they use this to allocate teachers, to promote them, to decide about whether they will have, they will be assigned to different schools and so on and so on. So this is quite important. There is quite a high stake here, because if you think that teachers are evaluated based on this measure, you want to make sure that they capture the real impact of the teachers. The problem is that they usually focus only on test scores, okay? So it could be math test scores, reading test scores, like different test scores, but the question here is that maybe they are missing one important part of the picture, that is the impact of the teachers on the students' well-being or the students' non-cognitive skills. That will be very important for long-term success of the students, and are not captured by this value-added measure. So if we look at this literature on teacher value added that is based on test scores, there seems to be a puzzle that is the following. So if we look at how this teacher impact evolves over time, we see that teachers have a huge impact in terms of test scores just the year they have the students in the class. But then when you look at the students' test scores in the year after, so 1 year after, 2 years after, 3 years after, and so on, and you look at whether you still see an effect of having this teacher in one particular year, you see that the effect is like fading out very rapidly over time, okay? So it seems that having a good teacher at some point matters a lot, but then the effect decreases over time very rapidly. But at the same time, there are studies, in particular by Rash, Chetty and co-authors, which show that having a good teachers in one particular year have huge effect in terms of long-term success, and it can predict that you will attend like higher education, you will have higher earnings, and so on and so on. So it seems to be weird to have an effect that is decreasing very rapidly over time, and at the same time that predicts long-term outcomes. So one explanation could be that actually those teachers who improve students' test scores, they not only improve students' test scores, but they also improve non-cognitive skills of students. And this is because they improve the students' non-cognitive skills that persist over time. The effects on these non-cognitive skills persist over time. And this explains perhaps why at the end you find this high effect in terms of long-term outcomes. Okay, so this is an explanation I also want to test in this paper. There are already some papers that have tried to look at this relationship, that I've tried to look at how teachers can improve non-test scores outcomes, so looking at students' behaviors in particular. So here I'm going to go a bit further with looking not only at behaviors, but also different non-cognitive skills. And I will look at how it can influence long-term outcomes, not only high school completion, but also university attendance, labor market aspiration, health, like other outcomes that are also very important in adulthood. So how do I do? So to do this, I use a UK dataset, birth cohort study, the ALSPAC data, which allows me to have information on both the students and the teachers in one dataset. And so I observe for different students that are matched with a teacher in the dataset. And then I compute this teacher value-added measure for students using information on math test scores, but also on non-cognitive skills. And to measure the non-cognitive skills, I use a standard measure of this non-cognitive skills, that is the strengths and difficulties questionnaire. So I will detail later on what is this questionnaire. And what I find, if you want to have a bit of a description of my finding here, I find that huge effect of teachers on both students' math test scores, but also on non-cognitive skills. I also find that there is some persistence in this students' non-cognitive, this teachers' effects on students' non-cognitive skills, and so the effects persist even after 8 years. A student had a certain teacher. I also find some cross-skill effects between so the impact of teachers on student math test scores and student non-cognitive skills. And in particular, I find that teachers who improve math test scores also improve non-cognitive skills in later years. Okay, so it kind of confirmed the hypothesis we had in the beginning, saying that could be that the effect on test scores is fading out over time, but at the same time, you have these effects on non-cognitive skills that persist and can explain the long-term outcome. And then I looked at the effect, these teacher effects, how they persist, looking at student outcome at age 20. So because I'm able in this data set to follow students, so when they are in primary schools, high school, and then at the age of 20. So I have information on whether they are going to the university, information on their aspiration in terms of labor market outcomes, but also health behaviors. So for instance, alcohol and tobacco consumption, and also whether, so I say attitudes toward others, but also whether they do volunteering or information like that. And so I can look at whether if in primary school you had a teacher who improved your non-cognitive skills, whether it had some effect on your long-term outcomes when you are age 20. And I do find some significant effect. Then I will not show you this result here, but I also try to investigate what explains a teacher value added in terms of cognitive and non-cognitive skills. So, and how much it relates in particular to teaching practices. So about the data, so as I said, I'm using the ALSPAC data, which is a birth cohort study, which collected information on about 70% of the pregnant women in the Avon area between March 1991 and February 1993. So it's about 14,000 pregnant women. And then, so the children they have been followed over time until the age of 20. So now they're actually older. So we could have information on them later on. And so we also have information, on the school they went when they were in primary school. So there were some school questionnaires that were sent. And so we know in particular in year 3 and year 6, so it's basically when they were age 8 and 11. So which teachers they had when they went to this primary school. So I can merge this information with the National Pupil Database. So this database is an administrative database in the UK, which gives you information on math test scores at different exams, so key stage exam. And so I have information on the math test scores at the end of year 2 in particular, and beginning of year 4. So which means that if you think at the interval between the end of year 2 and beginning of year 4, you can compute the gain a student will have between the end of year 2 and beginning of year 4 with the teacher they had in year 3. And same for year 6, because I have information on test scores beginning of year 6, end of year 6. I can compute the gain in terms of math test scores during year 6 for students and compute teacher value added then for students in year 3 and year 6. I can do the same with the non-cognitive skills, so using the strengths and difficulties questionnaire and compute so teacher value added in year 3 and year 6 in terms of non-cognitive skills. So to give you a bit more detail about these non-cognitive skills, so I compute using the strengths and difficulties questionnaire two measures. So the first one is called internalizing behaviors. This is a standard way to use this questionnaire. So this internalizing behavior, it captures, something that relates to emotional health of the students. So you have, for instance, question on whether the pupils often complains or had many worries or is often unhappy, things like that. You can also have question on the peer relationship. So whether the pupil is has at least one good friend or is generally liked by other children, stuff like that. So I just compute then an unweighted sum of all these questions, which give me an information on this internalizing behavior. And then I also use another measure, that is externalizing behaviors, using still the strengths and difficulties questionnaire, where here I have more information about a pupil's conduct, like how he behaves regarding the other children. So whether he often fights, for instance, with other children, or often lies, or also whether in terms of hyperactivity, like whether he's easily distracted or things like that. Okay, so I have these two measures, internalizing behavior and externalizing behaviors, and I will compute teacher value added measure using these two measures. And I also, in order to compare with test scores, math test scores, I also use an average measure of this internalizing and externalizing behaviors that I will call non-cognitive skills, just to have one figure that is summarizes these two scales. So I also have a lot of information on pupil characteristics, as I that I will include in my regressions. As I said, I have information on outcome at age 20. I also have a lot of information, because this is a birth cohort study, on parent characteristics that usually are not included in standard value-added models, and also information on school and classroom characteristics. Okay, I will skip that to go a bit faster. So as I said, the children were born between March 1991 and February 1993 in this data, which means actually, if you think about when they entered primary school, it means that they enter primary school at 3 different times. So you have 3 different school cohorts, actually. So it means that when they enter primary school and when they went to year 3 or year 6 in primary school, a questionnaire was sent to the teacher, and so it happens that sometimes I observe the same teachers twice in my data, or 3 times, because of these different school cohorts. So in particular, 34% of my teachers are observed twice and 80% are observed 3 times. So in my strategies, I will use the fact that I observe some of the teachers several times. So roughly, I have information on about 300 schools and about 1,000 teachers. And on average, I observe 12 students each year per teacher. So I don't observe all the students, because some of them were not in the ALSPAC data. But on average, so I have 12 students per teacher. So how do I compute this teacher value added measure? So there are 2 issues when you compute this teacher value added measure. First, you need to take into account selection issues. So the fact that perhaps some students will be, some teachers or some will be more likely to be assigned to some specific students, okay? So they are not randomly assigned, perhaps. And the other issues you want to take into account is the fact that perhaps you will compute this value added measure for a teacher based on the students' gains you observe in a specific year, but perhaps what you will observe will be quite noisy because you only see these teachers once, okay? Or perhaps you don't have a lot of students, you don't observe a lot of students for this teacher, so you need to take into account this fact that perhaps you measure this teacher value added with noise. So the first step is to compute so the gains students will have with one teacher, okay, during one specific year. So to do that, you will regress the outcomes. So why is it? Perhaps it will be math test scores or internalizing and externalizing behavior. On the math test scores and internalizing or externalizing behavior of the students in the previous year, okay, to have the difference, the gap between year T and year T -1, and a bench of control on students' characteristics, family characteristics, school and classroom characteristics. And you will also, of course, control for teacher fixed effects, okay, which will capture, okay, this average teacher effects in year T for the students assigned to this teacher. And so once you have this residual, okay, which captures this student gains in terms of math test score, internalizing or externalizing behavior in year T, then you can compute the average of this residual for a class teacher J in year T, which will give you the teacher value added of this teacher J in terms of math test scores or internalizing or externalizing behavior. Now, once we have this measure, this teacher value added measure, as I said, they might be noisy. So you might want to control for the fact that, for instance, they were computed on a small number of students because you'd only observe few students for this teacher. While for other teachers, you will have a lot of students that you observe in the data for this teacher. So what is usually done in the literature is to shrink the estimate that are the most noisy multiplying this teacher value added with by a coefficient that is okay, this Bayesian coefficient that will allow you to shrink, okay, the sum of the estimates toward 0 to give them less importance, those who are estimated with noise. And so if you look at this this figure here, you see that, for instance, when n is the number of students a teacher will have in year T, you see that when you have a small number of students, then this lambda will be close to 0, and so you will have the value added measure of this teacher that will be shrink toward 0, for instance. It also depends on the variation in terms of teacher effects, variation in terms of classroom, and variation at the students level. So once you get this teacher value added estimates separately for math test scores, internalizing behavior and externalizing behavior, then you can look at the distribution and how they predict different outcomes. So, of course, one issue to compute this measure will be students sorting, as I said, because it could well be that actually when you have this teacher value added measure, what you capture is not related to the causal impact of the teachers, but it's related to the type of students a teacher will get, which can predict how much they will progress, how much they will improve their math test scores or non-cognitive skills during the year. But it has nothing related to the teacher quality itself. Okay, so to kind of look at this, I will perform several tests to see, for instance, if a good teacher are more likely to be assigned to students with parents, with students from more educated families, for instance, or parents with certain characteristics. You can also try to perform other tests to try to check for an unobservable characteristic that might also be correlated with teacher value-added measure. So, but overall, what I find in the data is that once you have control for students, parents characteristics, lagged outcomes, classroom and school characteristics, at the end you have a limited amount of sorting in the data. And so somehow you can interpret the effects, the teacher value added measure as causal impact of the teachers. So now if we look at the results. So here are the results in terms of teacher value added measures. So when I compute this measure for math test scores, internalizing behavior and externalizing behavior, so in year 3, in year 6, and when I look at an average effect combining year 3 and year 6. So how do you interpret this measure? So for instance, if we take math test score year 3, so here you see an effect that is 0.096. So you will say that when you improve the quality of the teacher you have in terms of math test scores by 1 standard deviation, it will increase a student's math test score by 0.09 standard deviation. Okay, so this is what usually people find in terms of math test scores for the effect of having a 1 standard deviation increase in teacher math value added. But so what you can see here when you compare this effect in terms of math test scores with the effect in terms of non-cognitive skills, you see that, okay, the effect in terms of math test scores are higher, but the effect in terms of non-cognitive skills are also quite close to the math test scores effect. You see, for instance, that the effect in terms of internalizing behavior, there are 0.07, 0.5 or 0.6 for externalizing behavior. And the other thing that you can see here is that the effect in year 3 for teachers in year 3 and the effect for teachers in year 6 are quite similar. So it doesn't seem that, I don't know, year 3 teachers have more importance than year 6 teacher or the opposite. Now, I perform a lot of robustness checks in the paper to see whether when you change the number of students you observe per teacher, you have different results. I also use the different scales separately to see, okay, which non-cognitive skills are perhaps more impacted by teachers. So, okay, I will not go into details, but I performed several robustness checks, and overall, I found that the results are quite robust to this different check. Now, if you want to check for sorting, I also do several tests. I will only show you one here for the sake of time. So what do I do? So one question is whether, okay, good teachers are more likely to be assigned to, for instance, students with more educated, from more educated families, for instance. So what you can do is take the math test scores or the non-cognitive skills, and you kind of predict this math test scores or non-cognitive skills using family characteristics that you have, okay? And then you correlate this predicted outcome with your measure of teacher value added, okay? Now, if you find positive correlation and high correlation, it would mean that somehow you have sorting of your students based on family characteristics with teacher value added. Okay, some teachers will be assigned some specific students based on family characteristics. Now, if you look at what I find, I don't have any significant coefficients, And the correlation is very small for math test scores, but 0.004. And for non-cognitive skills, it's 0.06, which means that doesn't seem to be some sortings in my data based on family characteristics. You can do the same using lagged outcome, okay? And you will find again that at least teachers are not assigned to students based on students' previous outcomes. So I conclude that based on this test and other tests, that there are some limited sorting of students in my data, which kind of helped me to say that this teacher value added can somehow be interpreted as causal impact of the teachers on students' math test scores and non-cognitive skills. Now, once I have this measure of teacher value added, I can see how much they predict future math test scores or future non-cognitive skills of the students in the following years. Okay, so what I do is that I take my math test scores in the following years. So in year 6, year 8, year 11, and so on. And so I residualize this outcome using my information on students, family characteristics, and so on. And I correlate this with my measure of teacher value added in year 3 and year 6. And see how much having a good teacher in primary school predicts your math test scores or your non-cognitive skills later on, okay? So when you do that, here is what you get. So the first, the top of the graph gives you the information on how much having a good teacher who improves your math test scores in primary school, how much it will improve your math test score in T+3, T+6, and T+8. And you see that, so first, you still find a positive effect and significant effect 8 years after having this teacher who improves your math test scores. But if you look at the coefficient, they are decreasing over time, okay, which is consistent with the literature on teacher value added on math test scores. Now, if you look at what is going on in terms of non-cognitive skill, well, actually you find exactly the same pattern, okay? You find that the effect is still positive and significant 8 years after, okay? And the effect is decreasing over time, which means that you have the effect is fading out over time, but you still have some persistence 8 years after having a good teacher who improve your non-cognitive skills. Now, if we want to look at what happens in terms of long-term outcome at age 20, so you can do the exact same regression where you take your different outcome at age 18 and 20, and you regress them on the teacher value added you have in year 3 and year 6. So just a bit of clarification. So for each student, I, of course, only observe the outcome only once, okay? So I know, for instance, at age 20, whether they went to the university. Now, for the teacher value added, I have 2 measures per student. I have the one in year 3 and the one in year 6. So what I do is that I compute an average measure of the teacher quality they had in year 3 and year 6, and I correlate their outcome at age 20 on this average measure of teacher quality they had in year 3 and year 6. And here is what you have. So you see that having a better math teacher will increase so your math test scores by 1 standard deviation. Having a better math teachers by 1 standard deviation will increase the probability that you go to you graduate high school by 3.2 percentage point. Okay. Now, if you look at the effect of having a better teacher in terms of non-cognitive skills, you find an effect of 2.5 percentage points. Okay, so quite close to what you have in terms of math teachers' effect. You get the same if you control for family characteristics. Now you can also see what is going on in terms of university going, and you still find an effect of having a good teacher who improve your math test scores and your non-cognitive skills in primary school. Okay, you have an effect that is a bit higher for math, but you still have a positive and significant effect in terms of non-cognitive skills on the probability of going to your university. You can also look at earnings. So of course, at age 20, I don't have measure of earnings, okay, because you have few students, we have few individuals who are already on the labor market with a full-time jobs. So what I do is that I looked at expected earnings. So they have a question about how much they expect to gain at age 30. And you can correlate this with the teacher value added. And here, interestingly, you find a negative effect for non-cognitive skills. So it seems to say that having a teacher who improves your non-cognitive skills will reduce your aspiration in terms of earnings at for age 30. Now, if you look at whether they enjoy school or whether they have a clear idea about what they want to do in the future, here it seems that what is important is having a teacher who improve your math test scores, and I don't find any effect of in terms of non-cognitive teacher value added. But if you look at other outcomes, particular drinking, whether you drink 2-3 times a week at age 20, whether you have ever smoked, or whether you live with partner or you do volunteering, here for all these outcomes, it seems that what matters the most is having a teacher who improve your non-cognitive skills in primary school. Okay, so it seems that overall it's important to have a teacher who improve your math test scores, but also to have a teacher who improve your non-cognitive skills. For some outcomes like university attendance, graduating from high school, both are important, while for other outcomes like health and behaviors, it seems that non-cognitive, the impact of teachers on non-cognitive skills are what is really important. Okay, so this is just what I've said. So in terms of effect, you find the effect in terms of high school completion by 2.4 percentage points, university attendance by 1.2 percentage points. So quite, I mean, not negligible effects. Now, what is important is that this teacher non-cognitive effect, they come in addition to the effect in terms of math test scores. Okay, so it's not like if you could, so if you focus on non-cognitive skills, you will don't have the effect in terms of math test scores. It's really in addition to math test scores effect. And I also looked at gender differences, and I find that I don't find any clear difference between boys and girls for this teacher effects. So to conclude, it seems that from this analysis that the effect of teachers on test scores and non-cognitive skills are both important. Okay, so the question you may want to ask is then, is there any optimal allocation of teachers across the school curriculum? Like, should we have teachers who improve our non-cognitive skills at the beginning, and then teacher will improve math test scores at the end, or how should we play with this? you may also want to then improve this teacher's ability to enhance students' non-cognitive skills. So should we include something in how teachers are trained? So a specific module or something like that help them to improve students' non-cognitive skills. Overall, it seems very important to have to measure the effect of school policies and education intervention, both on test scores and non-cognitive skills. Otherwise, we are missing an important part of the picture, in particular the effect on students' non-cognitive skills that persist and have strong effects in the long term. But of course, there are a lot of work that still need to be done to understand what is going on, and in particular for these teacher non-cognitive effects. In particular, which non-cognitive skills are very important, which one should we focus on? And also in terms of heterogeneous effects. So I don't find any difference between boys and girls, but perhaps we could find heterogeneous effects based on family background or other characteristics that would be important to look at and to understand who we should target when we want to improve the effect of school policies based on non-cognitive skills. So I will stop here. Thank you very much. And I'm happy to know if you have any question and to discuss all these results. Thanks a lot.
Excellent. Thank you, Sarah. That was wonderful. I have a bachelor's degree in education, and I can attest to the fact that there was not any emphasis on teaching future teachers how to develop non-cognitive skills as you've defined them. And so I think this is extremely important and crosses many different elements of well-being. So thank you so much. I see that we do have a question already from Kelsey.
Hi, Sarah. Very interesting. You've done a lot of work, I can see, and have some interesting work to come still. I guess my first question would be, do you observe persistence in the value-added measures? So one student has positive value-added measure in year 3, and do they also have a positive one in year 6? And if you have looked at that, do you think it means they got into a good track that then could potentially explain where they're at the age of 20? And so it may not be that what it impacts them at year 6 or 3 is actually lasting all the way to year 20, but they just got into a good track.
Yeah, it's a good point. I think I have the result I tried. Yes, here. So you see, I tried to correlate whether okay, there were some relationship between the teacher you had in T-3 and the teacher you have in year T. Okay, and you see that there are some correlation, but they are quite small. Okay. And it's even negative here which means that if you have a good teacher that improved your non-cognitive skills in T-3, actually you will less likely to have a good teacher in T. Well, so well, there are some tracking, but it doesn't seem to be very high. It doesn't seem to be very important, at least in my data, but it could be different in other countries or different settings. But
yeah, I think this is actually a very helpful figure to suggest that it is in fact, somewhat random given your controls. Yeah. So I think that this is very helpful. I can lower my hand if others have questions for now.
Well, thanks.
Yeah.
Feel free to continue discussing. I don't see any other hands raised or any other questions. Are there any other questions? Oh, we do have one. Namho Kim.
Hi, Sarah. Thank you very much for really interesting and very important topic. I think my question is mostly related to the characteristic of the teachers who are good teachers who give a more value added. So I wonder if you have variables for the characteristic of the teachers. And I think that related to this question, what I want to ask is whether, I mean, the measure of the difficulty and what is that? The strength and difficulty measure that is observed by teachers. So I wonder if some teachers tend to give more generous scores to students. I think it might be important to see, because the fact that some teachers give like a more generous scores to students in general could mean that these teachers are particularly more attentive, or like having more effective like attachment to the students, which can in turn affect the students' performance and the non-cognitive skills. And the last question would be related to whether there is some difference between the math value added and the non-cognitive value added, whether they are always like going hand in hand, or they are, I mean, some teachers are really good at math value added, but low in the non-cognitive skill added value added, this kind of thing. Thank you very much.
Thanks a lot. Thanks a lot for your question. So regarding your last question, I will start with your last question. So when you look at the correlation at the teacher level between their impact in terms of math and non-cognitive skills, you find a very small correlation, or sometimes even negative, which means that some teachers are good at improving math test scores, and some are and at the same time they are not very good at improving non-cognitive skills. And so it's and the opposite. So it seems that they kind of specialize either in improving math test scores or either improving non-cognitive skills. Regarding your second question, so indeed in the data I have actually two types of information on this for the strengths and difficulties questionnaire, which is kind of interesting, because I know, so the teachers are answering the question for the students, so they rate the students using the strengths and difficulties questionnaire, but at the same time you have the parents that are answering this questionnaire. Okay, so you can actually compare what the teachers and what the parents are saying for the same students at the same time, okay, which is quite nice. And actually in the exercise I do here, I presented you only the results using parents' reports, okay, to kind of deal with what you just said, that perhaps teacher reports are kind of endogenous related to their value added, and so perhaps you don't want to use the teacher reports to compute this teacher value added measure. So far I only use parents' reports, but it could be that in the future you actually want to also use the information you have from the teachers to perhaps correct or control for, I don't know, but it could be interesting to use these teacher reports as well. But here in the result I show you, I only use the parents' reports. And regarding your first question on how it relates to teacher characteristics, so I did two things. It's not in the paper, but in previous version of the paper. So I actually have a lot of information on teacher characteristics. So I know their gender, I know their experience, their years of qualification, so stuff like that. So, and actually what you find is that when you correlate your value added measure with this type of information on the teachers, you don't find huge correlation. Okay, so doesn't seem that experience predicts their value added. In terms of gender, you find small correlation, well, it seems that female, women are kind of better in terms of non-cognitive skills, but it's a small correlation. Now, of course, it's kind of related to what is found in the literature. Like in the literature on test scores, what you usually find is that teacher characteristics don't predict much in terms of teacher value added in terms of test scores. But actually, what seems to be very important is teaching practices, not really the teacher characteristics, but what teachers really do in the classroom, okay, in terms of teaching practice. This seems to be the thing that is the most important to explain teacher value added. And in terms of teaching practices, I also have information in terms of homework or whether they work in group or whether you have a lot of discussion in the class or stuff like that. And so I try to compute using these different teaching practices, kind of average, like composite indicators, kind of related to modern versus more traditional teaching practices. And you seem to find that modern teaching practices, so having a lot of discussion in the class or stuff like that, seems to be positively correlated with value added in terms of non-cognitive skills. But it's not, so far it's not in the paper. This is, yeah.
Okay. Super interesting. Thank you very much. Just one additional question, if I may. So I think it will be also interesting to see whether the non-cognitive skills of the teachers may have impact on the students' and non-cognitive skills. Probably there's no data available for that, I guess.
You have some information on teachers' mental health or confidence in teaching, but when I correlate this with the value added measure, I don't find anything. Yes, okay. I think Kelsey, you also have a question.
Yes. So again, very interesting, very rich data. So as you know, I'm interested in teaching practices. And so I wonder how variation you have within school and basically how much data you have also, because I think the teaching practices may be more correlated across teachers within a school. So how much variation do you have across teachers within schools? Can you measure that? And kind of related, again, I'm just kind of thinking about the structure of your data. You have teacher fixed effects. How many students approximately do you have per student teacher, or is it really the variation that where you have, I think you said approximately 30% of teachers have repeated observations over time? So a little bit about the structure.
Yeah, no, it's a good point. So this is also why so far I don't talk about these results, because I think they are quite problematic in a sense that so you don't have at the school level. I didn't look at whether you had a lot of variation, but what I did is that I looked at the teacher level, because you observe some teachers several times, like whether you had some variation within teachers in terms of teaching practices. So you have some, but not a lot. Okay, so most of the variation are across teachers, but I didn't look at whether within school, like across teacher, you had. This is a good point. I don't know. I can't answer this question, but so most of the variation, at least, are across teachers, and the problem is with these teaching practices, and that you don't know, like whether so is it because they have specific students, so they adapt to the students, so they implement some teaching practices, and so that are also, well, it's kind of difficult to have an exogenous effect of your teaching practices on your teacher value added measure. Like it seems like you can have some correlation, but it's difficult to have a causal effect.
Yeah, it definitely makes sense. I'm trying to do a causal effect of teaching practices. So
I know,
yeah. So yeah, it makes sense. It would also just be interesting to see fixed effects for schools. And it would be basically a separate paper to see if there's certain characteristics of the schools that explain outcomes. And then you can look at the underlying teachers within the school to help explain characteristics of the school. But you might have infrastructure, administrative support, other aspects that might help explain also the teacher value added. Yeah. Okay. Thanks.
Well, yeah, I agree. Definitely. Thanks a lot for your comments.
I think we have time for one more question. Li Yapeng. I'm sorry, it says, I am sorry that my computer does not have a microphone. Okay, I can read this for you, Lee. Thanks for the topic. Besides math scores, does the teacher have any impact on the scores of other subjects? And does the impact of teachers vary by region?
So yes, so I have information on English test scores. So I try to compute this teacher value added on English test score as well. If I remember well, I think they're quite close to the effect in terms of math test scores. I don't want to say something wrong, but I don't remember if they are higher or smaller, but I mean, you can also look at the effect in terms of English test scores. In terms of variation by region, this I can't do because the data are they are collected in the Avon area, so it's related to the cities of Bristol and Bath. So it's quite small region in the UK, so you can't have variation by region. You're welcome.
I know there's so many more questions and comments. We have reached the end of our time allotment here. We're over an hour. So my final question for you, Sarah, is can we have you back for another webinar in the future to discuss?
Yeah, for sure. With pleasure. Thanks.
Also, hopefully you'll attend our upcoming conference and present as well.
Yeah.
Okay.
With pleasure.
Excellent.
Sure.
Excellent. So if you're listening in and you didn't get a chance to talk to Sarah or you have future questions, we'll be sending out an email follow-up with Sarah's email address so you can contact her, but also stay tuned. She might come back to us in the future for another webinar, and she'll also be presenting at the 2023 conference in Rotterdam, which again is taking place August 21st to the 25th. Just another reminder that the abstract submission deadline for that is January 15th. So please do consider submitting your abstract for that. Sarah, it was such a pleasure to have you join us. Clearly obvious why you earned that Young Scholar Award from ISQOLS. So thank you so much for taking the time. Thank you all for tuning in. And we'll be sending up that follow email pretty soon with the recording. So thank you again, Sarah.
Thanks. Thank you very much. Thank you all for your comments and for attending. Thanks a lot.
Thanks, Sarah. Have a great day.
Take care, everyone. Be well. Goodbye.
Bye.